Yeah. So this afternoon, we're going to look at two topics really. We're going to look at what we call ratio, and then we're going to look at what we call proportion. Right? So we can take them one at a time. They're very related topics too, right? Let's talk about ratio first. What do we mean by ratio? A ratio basically it's a mathematical relationship that is used to compare the size of two or more quantities. That's basically what a ratio is, right? Like let's just say somebody in this class is 25 years, and let's just say I'm 50 years, right? Um, so you can write that like this, right? So somebody is 25, I'm 50. And you can reduce it the way you reduce fractions, 1 to 2, right? You can write it like that. Ratio of your age to my age is 1 to 2, right? Simple as that. You see ratios a lot in real life, right? If you're used to let's say maps, if you come across maps, and you would see something like this on map, 1 to 100,000, something like that, right? This is a ratio. What it's comparing sometimes. This is referring to units on map, and this here is referring to units in real world, right? So basically, if you measure 1 centimeter on map, right, that would represent 100,000 centimeters in real world, right? So this is a real people who are into map reading and map drawing and geography and so, right? You see that a lot. Um, uh, on maps, right? Any map you pick up, you will see a ratio like this. It's really comparing the unit or the distances on the map compared to what it is in the real world, right? Um, you see ratios in okay, let's say recipe, right? You see ratios a lot in that. Maybe um, you're talking about let's say a smoothie, right? Smoothie. I hope I spell the word right. P-H-I-E, is it? I hope it is an I inside. Yeah, and maybe okay, milk too. Um, what else is in smoothie? Milk to chocolate to what else you put in smoothies? Let's say smoothie is fruit, no?
Yeah, sweeteners and stuff.
Oh gosh, so chocolate wouldn't be in a smoothie, right? All right, let's say fruit. Let's go with water. Water. I put in the water in the thing, right? Milk to fruit to water. So maybe there's okay, 2 to 4 to 1, something like that, right? So that means okay, if you put in a smoothie 2 liters, right? Let's say milk you mix it in bulk. You have to put 4 liters of maybe fruit juice or what, and 1 liter of water. That's what that means, right? So in recipes, you will see that a lot, right? And so on. You know, you see ratios all the time. You see ratios all the time, right? Um, Now, when it comes to uh, proportional, when you're talking about proportion, what we mean here now? What we mean? We talk about proportion. Proportion. What do you really mean now? Right? When we talk about proportion, well, there we can say that two quantities are said to be in proportion when corresponding pairs of values are always in the same ratio. So what's that now? Two quantities are in proportion if corresponding pairs of values are always in the same ratio. What am I talking about here? Okay, let me explain. So let's say you have, okay, 1 pen cost $100. 2 pens cost, I think this is an S here, no? All right, don't kill me for English. $200, right? 3 pens cost $300. Now, what you're seeing here, right? Let's take maybe I'll take the first two, right? What you're actually seeing here is that, okay, if you double the number of pens, right? You get, okay, you buy 1, you pay $100. You buy 2, you pay $200. So what you're seeing is that the ratio of, okay, number of pens, the ratio of number of pens is equal to the ratio of the price of pen. Is that what you're seeing? Right? Is that what you're seeing really? You get 1 to 2,
Yes, sir.
so you get 100 to 200. Same ratio, right? So you're saying that the proportion of the number of pens, right? Or the price of pens is proportional to how many you buy, right? So we can say that the cost or price of pens is proportional to the number of pens bought, right? That makes sense. If 1 pen is $100, one would expect that if you buy 2 pens, you pay $200. Of course, when it comes to sales and discounts and so, those will break the rules, right? Or somebody say buy 5 pen, get 1 free, you know, that would go against what I'm saying here, right? But generally, when we look at the information given, you're seeing that the cost or the price of the pen is proportional to the number of pens you bought. So cost and the number of pens, right, is in proportion. Those two quantities are in proportion. Why? Because we see what? This is the number of pens, 1 to 2. The cost will be 100 to 200. They are equal ratio because 100 to 200 can be broken down to 1 to 2. right? So they're of the same ratio. So two quantities, right, will be in proportion if corresponding pairs, right, are of the same ratio. That is what that is saying. So now you're introduced to this matter of ratio and proportion. Well, maybe we can, maybe do an example or two. Let's do an example or two, right? All right. We'll borrow some from the notes I sent you. Let me borrow this simple one. Can you see this one?
Yeah, seen it.
Good. So, simple problem. You have a cricket club, there are 50 people, 50 members inside, and they give you a clue, 28 are female, right? So, could you say, before we move on, how many male members will there be? Number of males would be equal to what? 50 minus 28? How much is that?
22.
22. Great. Good, because we'll need this information. So they want you to determine the ratio of female members to the total number of members. So you can put female is what? 28 to 50. Very simple. And you will try to reduce this, right? Reduce it down. So let's see, if you divide this by 2, you'll get 14, right? And you'll get 25. And I don't think you can reduce that any further, right? Next, you want male to female now, male to female. So there are 22 males, so you put 22, that's part 2. 2, female is on 28, right? Let's see, and divide that in by 2 again. You get 11 to 14, right? And then they say male members, the total, right? So male is 22 to 50, right? Divide that by 2, you get 11 to 25. Right? Very simple one. Oh my, what did I do there?
So isn't 22 to 50?
Yeah, 22 to 50. So you divide by 2, you get
I was looking
11
at
to
22.
25. Right? So sometimes you can do that. You can you can reduce them to the lowest, right? Let me give you another one. Let's do a few examples with it. For this one. See this one? So you have some kind of drink, 300 centimeter cube of drinks, right? That's same as 300 milliliters. 1 cm cube is 1 milliliters, right? Like a small drink. It's made by mixing 50 cm cube of concentrate with water. So right away you can figure out how much water is in this thing. Water will be equal to how much? Or water in mix will be 300 cm cube minus 50 cm cube, right? So that's 150. Right? It's a real water don't drink, man. No, that's 250. 250, right? Cm cube. So the ratio of water, concentrate to water, will be 50 to, oh, I think I kind of, all right, yeah, 50 to 250, right? And you can probably break that down to, well, 50, 1 to, how many 50s in here? 4, 1, 5, 1 to 5? Huh?
Yeah, 5 stone. Yeah.
Yeah, right? Simple one. Okay, let's take another one. That might be a little more involved. And this will involve, remember we talked about proportion? Oh my, well, yeah. All right, good. Look at this one. So it says Alvin buys 8 meters of wire netting to make a chicken coop. You all know it's a mesh, right? This cost him $504. Mark is also making a chicken coop. He needs 6.8 meters of wire netting. How much will this cost? So what you're seeing here is a case of both ratio and proportion, right? Because what you're seeing is that the length of wire netting, right, is proportional to cost. Is that what you're seeing? The length of wire netting is proportional to the cost, right? So 8 meters cost $504. So the question is 6.8 meters cost, well, let's call it X dollars. Right? We don't know that. We don't know that. But what we do know is that the amount of wire mesh that you're going to buy is proportional to the cost, meaning they have the same ratio. In other words, and this is another way of writing ratio. It's true you can write it like this, right? You can write, okay, 8 to 6.8 has the same ratio as 504 to x, right? But you can also write it as a fraction. You can write it like this. 8 over 6.8 is equals to 504 over x. Right? You can write ratios as a fraction as well. Right? And now you have an equation here that you can solve, right? You have an equation here now that you can solve, right? And well, if you were to cross multiply, and so you have 8x equal 504 times 6.8. Therefore, x is going to be equal to 504 times, maybe somebody can help me with this, over 8, which is going to be 504.
428.4.
Yeah, that's correct. 428.4, right? So the cost then, the cost of 6.8 meters of wire, what is it, wire net, would be equal to $428.40, right? So it's a classic example. It's a classic example of ratio and proportion, right? So the cost of the wire net is proportional to the amount or the length of wire netting that you buy, right? Because they're the same ratio. The ratio of the length will be equal to the ratio of the cost. And in just a moment, I'll switch to something called direct proportion, because this is an example of what we call direct proportion. And we'll do something called inverse proportion.
So I'll do a next one.
Yeah, I'll do another one. Okay, we had one that I spoke about maps and so, right? Oh, this one, I don't think I can. All right, I'll give you the diagram for us. Look at this one, right? Well, we can't measure on this map, just like I was saying. Because we're online, we can't measure on the map. But I'll just paste the answer. Okay, good. Good. So let's look at this one. I don't know if you can see it. So it's a map of, I think this is somewhere in Jamaica, I think. I don't know, somewhere. So, excuse me. The map
Bless
has a
you.
scale of 1 to 50,000, right? And they want you to find the distance between Dung Farm, that's here, to Start Farm, that's one. So you want to find this distance here, right? And then Skeleton to Hairstone. Here's Skeleton. Skeleton, right? So you want to find the distance. And they mean the real distance, right? Between the place in km. So, well, they did the measurement for us. I can't measure from here to here and know it's 2.4, right? So they measure from Dung's Farm to Start Farm, and it's 2.4 cm, right? So we know that the scale says 1 to 50,000, right? In other words, 1 unit on the map represents 50,000 units on the real ground, right? So this is a case again where the ratios, right? The ratios are in proportion. In other words, okay, 1 to 50,000 and then 2.4, sorry, is the distance from Dung's Farm to Start on the map. So it's going to be proportional to, I don't know, right? Let's say X again. Right? So what they're saying is that the ratio of the units on the map is in direct proportional, it's in direct proportion to the distances in the real world. Right? So you can write this like this: 1 over 2.4 is equals to 50,000 over X. Right? You do a little thing and find X, right? So X then is going to be equal to 2.4 times 50,000, which is what they did here, right? And you get 120,000 cm, which they convert to meters and then km, right? And the same reasoning is used here, right? The same reasoning. If you have 1 to 50,000, then if you have 4.3 on the map, that would represent X. I don't know what X is. Again, you write it like that. You write it. Let me go back here in the space. 1 over 4.3 equal 50,000 over X. And you find X, right? You cross multiply. And you get X equal that. You do the multiplication, convert it to meters, then convert it to km. Right? The reason why is that the units on the map is in the same proportion, right? Or the ratio of the units on the map is in the same proportion as the ratio of the distances in the real world. Think you get that?
Yeah, I got that, sir.
Yeah. Right, it's a good application of it. A good application of it. Good. Now this, as I said before, this kind of problem is a classic example of something called, and that's what we're going to look at now. Right? There's something called direct proportion, and that's a kind of direct proportion. And then there's another type called inverse proportion. Right? So what we've been dealing with is this here, direct proportion. We're going to also look at inverse proportion. Before I go there, do you want a little break and then we come back and tackle these two, or you want us to do them now, or do one and then give you a break? You tell me.
Finish the direct, sir.
All right, good. All right, let's do that. I was thinking the same thing, right? Okay. So let's deal with the direct proportion one, right? Let's deal with that. Direct proportion, right? And we'll take a little break. Good. So two quantities are said to be in direct proportion. We didn't use the word direct earlier. We just said the two quantities are in proportion, right? If their ratios are equal, right? That's what we said. So here we talk about two quantities we say are in direct proportion if they increase or decrease by a constant multiplier. Right? And it's saying the same thing really. Like how we say, all right, 1 pen costs $100, I think he said. I think you're supposed to use the word costs, no? 2 pens cost $200. Right? So what you're seeing here is that when you double this, you double this. Right? So what you can say that the number of pens is directly proportional, how is this word spelling? Proportional to the cost, right? We're seeing that. Because when you double the number of pens, you double the cost. You triple the number of pens, 3 pens, what am I doing? Cost $300. So when we triple the number of pens, we triple the cost, right? So we say that there's a direct proportional relationship between the number of pens and the cost of the pens, right? There's a direct relationship. And there's a very Well, we did just now where you can write this relationship as ratios and find unknowns, right? We did examples like that. Like let me just go back a little. Like here, right? The textbook didn't do it like that, but I did it. Watch. The unit on the map 1 to 50,000, and the unit on the map against what is in the real world 4.3 against what the distance is on the real world, and I wrote it as a fraction, right? And I cross multiply and solve it, right? So you can do this. This is a classic example of direct proportion. There's another way of writing it too, and I'll delve into that a little, like this here. So you can say that, all right, you can actually come up with a little formula, like, you know, cost is proportional, is proportional to the number of pens you buy, right? So you're saying that, okay, if C is cost and N is number of pens, then you can write C is proportional to the number of pens. In other words, the cost is proportional to the number of pens. To remove this proportionality sign, you can introduce what we call the constant of proportionality. You can say C is equals to Kn. And your next step is to find what K is, right? You can find what K is using information given, like, okay, we know that C equal 100 when N equal 1, right? So 100 equal to K times 1, right? So that implies that K equal 100, right? So now we have a formula. So C is equals to 100N, right? C is equals to 100N. So we actually now have a what they call a ready reckoner, a little formula that will quickly tell you that, okay, if somebody I want 10 pence, or how do you know how much you got to pay? 10 by 100, right? So you have a formula to guide you. You see? So this is another way. It's a more algebraic approach to direct proportion, right? And you'll see how it becomes useful when we do what we call inverse proportion in just a moment, right? So let's take an example or two, right? Let's take an example or two. We did an example or two already, but we'll just do two more. And I'll do it a little differently from how the textbook did theirs, right? So I'll do it exactly how they did theirs. So let me cut it and bring it here. Good. Look at this one. Right? It's true, based on what we did before, you can work this problem this way. So you suspect that the amount of petrol used is proportional or is in proportion to distance traveled, right? Travel. Good. So, all right, they have 6 liters. 6 liters how do you write this? Amount of petrol, 6 liters. All right, is proportional to, all right, 180 km. Let me put it that way, right? They want to know how many liters of petrol will be needed to complete a journey of 540 km. So we don't know this. X liters is in proportion to 540 km. Right? So we can write that this way. We can write it like this. Can write it like this. 6 over x equal 180 over 540. Right? You can do it like that. And we can do some cross multiplication. So we have 6 by 540 is equals to 180x. X then will be equal to 6 by 540 over 180. I kind of set it down a little inverted, so I know you wouldn't like it. All right? So we can actually get x. And can somebody help me calculate x?
I get 0.03.
That can't right. How do you get 0.03? If you're taking 6
Four.
liters to travel 180 km, how are you going to get to travel 540 km?
Sorry, 18. 18.
Okay, good. That sounds right.
Yeah.
18. Oh, God. What's going on here now? Yeah, 18. 18 liters, right? Yes. So that's one. That's one way. Another, what's going on here now? Some weird, my computer is malfunctioning. Yeah. Good. So that's one way. What I want to do is go in a different way now, right? I want to do it a different way. So I want to make use of that algebraic approach, right? That algebraic approach I was telling you about just now. So this is how I can do it. I can say, okay, let the amount of fuel be, you want to go with F, right? Let the distance be, let's call it D. All right, good. So we suspect that there's a direct relationship here between the amount of fuel and the distance that's going to be covered. So F is proportional to D, right? So you write it like that. They're directly proportional. So from this, to eliminate this proportional sign, we want to introduce what we call it the constant of proportionality. So F is equals to KD, right? K being the constant of proportionality. Now we can evaluate K because we're given some information, right? Given F equals 6 and D equal 180, find D, not K, sorry, find K, right? So 6 is equals to K times 180. So K then is equals to 6 over 180, which will be what? 1 over 30? Is that right? Good. That sounds right, right? Good. So let's see. So our formula now becomes F equal 1 over 30 D. Or if you want to write it like this, F equal D over 30, right? So now we want to find, as the information says, we want to know how much liters of petrol will be needed to complete a journey of 540 km. So for D equal 540, F will be equal to 540 over 30, and that will give us what?
18 again.
18, right? 18 liters there. You see? So that's a very, what do you call it? It's a an algebraic approach. Good. So let's take a break now.
Okay, sir.
Okay, so now it's 6, or let me say 6:25, 6:35, 6:40. We come back. 6:40.
Okay,
right?
sir.
And we look at inverse proportion, right?
Yes, sir.
Good. So what we were going to turn our attention now to is something called inverse proportion. So what are we talking about here? Now, when we were talking about direct proportion, and we were looking at two different quantities, when one is double, the other one is double. Inverse proportion is not like that, right? When one is double, the other one is halved. That's how it works. Like, okay, let's say, all right. Let's say two men, this is an M, right? Men does a job, right? And I'm assuming that this job is the same thing we're talking about in 4 days. If I were to double it, 4 men will do the same job in how many days? If 2 of them does the job in 4 days, how long you think 4 men will do the job? Same job. Hmm?
2 days.
2 days, yeah, 2 days. So what you see happening when you double the number of men, the time it takes is half, right? So times 2 times a half. So when one quantity is doubled, right, the other one is halved, right? So what is happening really is that the ratio here, 2/4 is equal to not 4/2, no. 2/4 is equals to 2 over this 4, right? This 2/4 comes from here. And this, I think I use a wrong, I should have used another set of numbers. Let's go with 6 days here, 6 days here, and 3 days here, right? So I'll end up with, all right, let me use 6/3, right? Yeah, so this will be 2/4 is equals to 3/6. So what you see happening is when one quantity is doubled here, the other one is half, right? So the ratio of this over this is equal to not this over this, but this over that, right? And with that now, you can be able to solve certain problems that involve what we call inverse proportion, right? Maybe we can do an example or two. It's strange. Okay. Oh, yes. Yeah, nice one here. But look at this one. I'll cut it and bring it over. Good. So look at this problem. They said 12 men produce 700 watches in 9 working days. How long will it take 18 men to produce the 700 watches? Right? So, okay. Don't get distracted with the 700 watches. That's the job. Right? That's the job. We want to look at the proportions now, right? So 12 in 9 days. Let me use the working days, 9 days. And 18 in, we don't know, X days. So remember, we're not going with direct proportion. We're not writing 12 over 18 equal 9 over X. No, no. We're going with 12 over 18 will be equal to X over 9. The ratio is inverted, right? The proportion is not direct, it is inverse. So we'll now have to do a little cross multiplication and see what happens. So we get 12 by 9, how much is that? Equal 18 by X, right? So you can okay. Just avoid 9 1s, 9 2s. So you get 12 equal 2x. So x then will equal to 12 over 2, which is 6. Right? And it makes sense. 12 men do it in 9 days. 18 men is going to do it in 6 days. Right? So careful that you don't put 12 over 18 equal 9 over x. You have to flip one of the ratios. One of the ratios got to be flipped. Right? Now, there's an algebraic approach to solving this, right? Keep the 6 as the answer in mind, right? And there's an algebraic approach to solving this problem. Let's look at it. It's not erasing that. Oh, good. So, as we said, there's an inverse relationship between the number of men, and the time, right? So, in other words, we could put it like this. All right. Let T be the time for the job, right? Let N be the number of men, right? So T then, we will say is inversely proportional to 1 over n. We're not dealing with direct proportion. If it was direct, we'd have T is proportional to n. But with inverse proportion, you say T is proportional to 1 over n. And we can now replace this sign with T equal K times 1 over n, or T equal K over n. Right? We now have to evaluate K. Right? So evaluate K. Right? So what we're going to do, we're going to put some numbers in that we're given. When n equal 12, T equal 9, right? So, okay, 9 equal K over 12. So K is equals to, what is it, 108 is the right number? Good. So our relationship becomes this now. T is equals to 108 over n. And we now have, like, as we said earlier, like a ready reckoner, a formula that could tell, you know, so you're running a little business and you say, well, look, if I get so many people, the job got to take so much time. If it takes more than that, something wrong. Right? So let's see if we'll get our 6. So when n equal how much? How much is it? 12? 18 men, right? 18. T equal 108 over 18, which is it 6?
Yeah, the answer is 6.
Yes. See, so that's an algebraic approach to solving the same problem. Right? So you come up with this relationship that T, you can write it, it doesn't have to be written like this. You can write n is proportional to 1 over T2. It's the same thing. Let's do another one.
Yeah.
All right, let's try another one. Fetching it over, so it takes a little while, right? Look at this one. So a field of grass feeds 36 cows for 4 days. How many days would the same field feed 20 cows? So just as a kind of guess, we're reducing the number of cows. Will the days increase or decrease? If we reduce the number of cows, will the number of days increase or decrease?
Would it increase?
Yes, it will increase because I got less cow. Right? The field will be able to feed them a little longer, right? So there's an inverse relationship, right, between the number of days and the number of cows. So we can say, all right, let T be the number of days, right? And I use T because we say time, right? Let N be the number of cows. So in other words, T is inversely proportional to the number of cows. We can write that back as, T equal K over N, right? We know that T equal 4 when N equal 36. So 4 equal K over 36, right? Which implies that K equal 4 by 36 is how much? That's right.
Yes, sir.
So the relationship becomes T equal 144 over N, right? So let's apply the formula now. So we get a formula now connecting T and N. How many days would the same field feed 20 cows? So when N equal 20, T then would be equal to 144 over 20. And what will we get? Will we get a nice number?
72.
Okay, 72. That doesn't sound right.
7.2.
7.2, yeah. I want to know 7.2 days, right? Yeah.
Yes, sir. 7.2.
Yeah. So, so that's the algebraic approach. Of course, you could go with the old approach, right? If you think this is tedious, right? Let me just show you what that old way. Anybody writing or anything?
Yes, sir.
All right. That's why I'm not hurrying to take it off. So let's go with the old way, right? So, all right. So let's put down the numbers. 36 cows, 4 days. 20 cows, X days, right? Good. So we're dealing with an inverse relationship. So 36 over 20. It can be equal to 4 over X, but X over 4, right? So you have to solve for x. Do that, do that. 36 by 4. X then will be equal to. And you should have your 7.3. Right? You just have to be conscious though that you don't put 36 over 20 equal 4 over x. You have to flip one of the ratios. That's all. Think you get that?
Yeah, that one way easier.
Yeah,
Yeah.
whichever. It doesn't matter which one you like. Main thing is that you understand what is meant when we talk about direct proportion and inverse proportion, right? Good. So on the Moodle page, I got some notes. They have more examples in the notes, right? And they have some other examples and so there that you can read through and see if it makes sense to you, right?
Okay,
I think I
sir.
have 2 sets of notes for you, not one. Right? Read through them. I think one of the notes got something on percentage and average. We'll deal with that Monday. So don't worry that we didn't cover that. We're covering that Monday. Right? Good. So we can stop there.